Welcome to another mathematical moment from the American Mathematical Society. I'm Max Levy, and today I'm talking with Dr. Alex Best, research engineer at an AI company, Harmonic. Welcome, Dr. Best, and thank you for speaking with us.
Yeah, thank you for having me, Max.
So I want to start a little bit with, this connection between AI and math, and I'm curious if maybe we could start with maybe a better understanding of how you got to working in this space. I'm curious if you can tell me the
Mm.
story of like how you got to blend these two worlds.
Yeah, so I can start at the beginning. So I was doing mathematics. I was working in a field called number theory, and I was kind of really excited about that. And I was working on a lot of kind of computational number theory, so writing a lot of algorithms, computer code that did things that were interesting to number theorists. So that's quite far away from where I ended up. And there was kind of like I guess a period of maybe sort of 7 or so years where I kind of got closer and closer to where I am now. The first thing for me that I learned about that was really interesting was a field called formalization, which is sort of a blend of programming and mathematics. So it's expressing mathematics, so making mathematical concepts into little pieces of code and sort of mathematical arguments into pieces of code so that a computer can understand them. And what that means is actually that a computer can check your mathematical arguments make sense. So it will give you an error if you write in one of these formalization languages when your argument has a gap in, right? So you might have like forgotten to consider, I don't know, the fact that some number could be negative, right? And you made some proof based on that, or some mathematical argument based on that, and the computer now would be able to tell you that you had a gap in your argument. So I found that really exciting because it sort of combined two things that I was really interested in, which is mathematics, also programming, and in some way it kind of let me, do both those things at once, and sort of not have to repeat myself, maybe, not have to write the mathematics and then write some code that reflected it, but kind of to combine both these things. So this has been around for a while, but it's kind of really taken off in the past, 10 years, let's say, among mathematicians.
So it seems like a big goal, teaching itself math and being better than a human in math. It seems like a big goal. Oh, was that your sense when you started that it seemed like a big faraway goal? Is that your sense now that it still seems like a faraway goal? How do you make sense of, the the, the how ambitious that is?
Yeah, I think it's definitely ambitious. I think the thing that makes it sound sort of not completely ridiculous is that there is by now a pretty well established kind of principle in AI research that, if you take something that works pretty well and you scale it up, it tends to just keep getting better as long as you scale it up, in the right way. And I think we've seen sort of many fields now, um, where these AI kind of models were pretty good at something, and humans, people thought, okay, this is as good as they're ever going to get, because we obviously have something that the algorithms don't, um, and then a couple of years later, a big advance came, and suddenly the computers were way better than humans were. And I think we've seen that principle, that kind of, I don't know, thing, that storyline play out several times now in sort of different um, kind of sub problems that people have applied AI to. If you go back 10 years, AI, algorithms, computer code struggled to recognize a picture of a cat. And now we have these sort of incredible tools in only 10 years. So I think it's ambitious, but I think the field has advanced so rapidly that it's not unbelievable that this could be possible and achievable in the next few years. Yeah.
How do you think about the importance of explainability and transparency of AI in this area?
Yeah, I think one of the interesting things about formalization specifically is that it is kind of explainable in a way. With some versions of AI, it might produce an answer for you. You might ask ChatGPT, for example, what is 7 plus 3? And it could say 11, right? There's no reason why it couldn't. So one way to mitigate that is to use this idea of formalization, where instead of asking for an answer, you ask for an answer and a machine checkable proof that that answer is correct. And so that's a way in which AI can become more explainable, is where you don't just ask it for an answer, you ask it for an answer and an independently verifiable, like a certificate that its answer does what it was meant to. And of course, arithmetic is a really easy problem, but there are many kind of more examples where that can be a really powerful idea. So for example, when you write software using one of these formalization packages, you can actually write a mathematical proof that the code does what it's meant to, right? So if, for example, you're writing a piece of code that was meant to put a list of numbers in order, then if you tried to write that, you could easily make a mistake. A human could, and so naturally, a large language model could make a mistake in the same way. But when you come to proving that the code is correct using a language for formalization, you'll realize at some point that there's a mistake, because you'll be sort of unable to complete the proof. And sort of the process of trying to prove it will often kind of reveal where the mistake was. And the mistake could be something really easy, right? It could just be that you forgot about the list with 2 elements. I don't know, that was your base case and you forgot to check that one. Or it could be something a bit more subtle. But this question of explainability and interpretability, I think is one of the really cool things that the formalization does, is it allows you to mitigate that somewhat. I say somewhat because the hard part sometimes is to sort of, even when you've got this machine checkable proof, if you can't read it, sometimes that can still be a kind of an issue for you. But the idea of these formalization systems is that even if you can't really read every detail, that you can still trust it sort of 100%.
Can AI be as creative or as, clever in problem solving, or I guess in this case, in proof finding as a human? How do you think about how those abilities can emerge, so to speak?
Yeah, I think it's a great question. And I think we've seen some examples of things like ChatGPT, right? Large language models being creative, right? You can kind of ask it in a creative writing kind of way, write me a fantastical story, and it might come up with something about, a 3-headed dragon or something. Okay, maybe a 3-headed dragon has been done before, but see, I'm not creative either, right? All I've done is I've taken something from Harry Potter, I think, I don't know, from one of these stories, and I've kind of regurgitated that to you as my example of a creative idea. In some sense, a lot of human creativity is the same. If you look even at math, a lot of the really creative ideas actually came about from someone thinking really hard about a subject and looking in a lot of different areas for inspiration, and taking that inspiration and making something that was new and really clever. But it's not always completely out of thin air, even for a human. So I think I see this kind of question of can AI be creative as an interesting one, but I don't see any real reason why AI can't do the sort of thing that humans do, which is to kind of look at a wide variety of things and kind of synthesize something that's kind of similar to all of them. But actually, when you write it down and crystallize it into sort of an idea in a pure form, kind of looks really different. But it's always inspired by something that you've seen before.
What has been the most fascinating use of AI in math to you so far, even if it's outside of formalization, in or out?
Yeah. I mean, there've been a couple. I guess I know the ones from my own kind of area of math the best. But there was one really interesting project that started out, I think, as an undergraduate project, where in number theory we studied things called elliptic curves and things called modular forms, and from these you get sort of a sequence of numbers that mathematicians have studied for 100 years or so. And so you have the sequence of numbers of integers, and despite being so long studied, there was a student project to run sort of an AI system, sort of train an AI to predict these. And it started doing better than kind of expected, right? There was sort of a limit on sort of what humans thought. We thought we kind of knew everything about, not everything, of course, but we thought we knew so much about this topic that maybe something like this couldn't sort of be lay undiscovered. So when it started predicting things better than the humans kind of thought that it could, they went and they looked, and after taking this to various other mathematicians, eventually an explanation was found. And so now this has become a sort of a whole area of number theory. The field is called murmurations, because when you look at these sequences, people kind of expected them to be sort of random. Within a certain range, there was just sort of random integers. And what they noticed, what the AI noticed, that then when they went and looked and tried to understand how it was making such good predictions, they found was that these things actually kind of formed a kind of slowly oscillating wave. And so the points kind of clustered together and they looked like a flight of birds. So that's why they called it murmurations, right? So this really beautiful thing in a really well-studied subject that was only discovered because somehow using an AI to predict it, where the AI didn't have maybe the sort of the background kind of what should and shouldn't be possible, right? No one had told the AI that making this prediction was sort of not believable, right?
What would change in the world, or at least in mathematics or mathematics and science, if computers could, do math better than humans?
Yeah, it's a great question. I think many things would change. Many things would stay the same. I think chess is a great example, where at some point humans were better than the machines at chess. And pretty early on, I think in the 80s, a chess program was written that beat Garry Kasparov, Deep Blue. And I think at the time, maybe some chess professionals or commentators thought, okay, well, chess is kind of solved now, right? Computers are better than humans. Like, why bother? And yet we've seen, I mean, chess continues to be really popular. There's world championships with prize pools. Spectators watch it. People watch chess videos online. People publish and read chess books. So the intellectual challenge for humans of understanding something and improving at it hasn't really been dulled by the fact that humans are no longer sort of the best entities at doing it. If anything, people kind of learn collaboratively with computers, right? They might propose a move in chess and then have the computer go and compute a bunch of continuations, right? A bunch of ways that the game could play out, and tell them, oh, this move is good, this move is bad. And so humans can now learn faster when learning chess because they have this sort of assistant. I guess my envisionment of how AI and math will play out would be something like that, right? Where we're doing mathematics, a lot of us fundamentally because we enjoy it. And I don't think the enjoyment would be any less because we had a really great assistant who could, help us out with our ideas and kind of come up with new ones and, critique our ones or, suggest connections that we hadn't thought of. I think that would just make it, even more interesting personally.